It's my pleasure to introduce our next keynote speaker, who's Laurence Murphy, who's from the University of Salford. And he not only is from the University of Salford, but he also is the UK representative for the Society for Motion Picture and TV Engineering, which is a standards body for that for media activity, video media. A bit of background about Laurence Murphy. He got his master's degree from the University of Salford and his first degree from Manchester Metropolitan, so he's a local lad. His current role is he's the program leader for a bachelor's course, a degree course in media technology here at the University of Salford. Which really is teaching the students how to manage new technology in TV distribution. His background has many years background as a broadcast engineering, and he in fact was doing his master's degree here while he was working for Granada TV. So, we were discussing over lunch, his philosophy very much is about pulling together the disciplines of broadcasting and telecommunications, and it's that marriage which fits very nicely into our theme, and hopes to bring out the next generation of engineers with that sort of skill. So it's my pleasure to hand over to Laurence Murphy.
Thank you, Andy, for that nice introduction. What I'm going to be talking about today is how broadcast engineering has evolved, television engineering has evolved, and there's been a marriage and nobody's noticed, and that's the marriage between broadcast engineering and comms engineering and their interdependency. So broadcast television is evolving. Traditional television distribution, it's changed significantly in the time I've been teaching. I've been teaching for 18 years, and we've still got a large terrestrial and satellite and cable footprint, especially across Europe, and they've changed direction, and we've significantly altered the future of media distribution for both cinema and television, because I know cinema didn't sort of register a little bit in the earlier sessions, but cinema distribution is a significant factor of the next generation media distribution as well. So the collaboration, involvement and extension of the use of traditional comms technologies has really radically changed the way the industry is working. It's radically changing the way it's perceiving new technologies, new implementations, and how we move towards the future. So there are key issues. When we change standards, traditionally we used to design a standard, put a launch date, build up to it, launch those technologies. As long as we had the business case, of course. I mean, 5G's got the same challenge. It's got to make the business case for launching it. What's happened recently, especially over the last 10 years, is that we've started to adopt more fleet of foot solutions and worked with communications backbones to actually enable release of new technologies before we've actually adopted them in a large scale in traditional broadcasting. So there are some common issues. I mean, compression is a big issue. Usable bandwidth. You know, I always say to my students, nothing happens without it all comes back to bandwidth. How much have you got? How much can you buy? How much can you monetize? How much can you actually deliver to the public? Then there's the network issues. We had some interesting talks this morning about how we prepare next generation networks to support new media, distribute it, make it accessible. And we're not just dealing with networks working with a traditional tool set either. We're actually changing protocols. We're actually retrofitting protocols within video engineering to circumvent some of the problematic areas of the stack so that we can actually make delivery more efficient and more cost effective. That's partly where we look at content delivery networks and OTT providers. Now, over the top has taken on a massive significance in the last 10 years. I mean, we saw Netflix and Amazon Prime actually included in some of the earlier sessions. But content delivery networks and OTT have given us the opportunity to leapfrog the traditional bottleneck of standards and distribution and changing the whole infrastructure before we adopt a new standard, changing the whole infrastructure before we actually can show people the next generation of technology. Fixed line and mobile comms networks constitute a significant media delivery infrastructure now. So there's a lot of forward thinking going on in the earlier presentations, but we'd have a significant problem if we didn't have that marry up with the communication networks. But they also have significant potential to expand, which traditionally terrestrial television, terrestrial engineering, we haven't. I say to my students, you know, we can't break the laws of physics. There's only so much spectrum we can actually transmit in. What we can do is bend it a little bit and make it more efficient and get more value out of that spectrum. And it flags up these common values and these common challenges between the traditionally two disparate industries. Look, 10 years ago, you know, we wouldn't have been having these conversations, 10, 15 years ago, It was comms over here, broadcasting over here, Now, it makes sense. We actually work together and we collaborate and we work towards a more unified project for the future. And the UHD was mentioned before. UHD really is a really good example of this. I like starting arguments. I got booed at an academic conference once. When 3D was coming out, I got up at a conference in 2009 and said, this 3D stuff's interesting, but 3D television won't work because it can't supply material to the whole public, so it won't work as a mass infrastructure. At that point, I got booed. And I followed on by saying ultra high definition has got that potential, but we just need the infrastructure to be able to support it. Well, we've now got that infrastructure because of the collaborations between communications engineering and broadcast engineering. And there's an interesting debate going on at the moment. This is very topical. IBC's in a couple of weeks' time over in Amsterdam. And there's a few question papers about whether we should actually call broadcast anymore, because the next generation of media really isn't broadcast anymore. That's what I was trained in, but it's changed, it's hybridized, it's moved towards interactivity, two-way communication, much broader standards. When I was training, it was one standard, it was PAL, that was it. Now we've got to learn, we've got to be more fleet of foot, we've also got to be more adaptive, and adaptive engineering is what we need. And there's no better example of adaptive engineering than bringing together broadcast engineering and communications engineering. So, comms companies are in an interesting position to affect, collaborate and lead. Now this is going to sound weird from a broadcast engineer, but I think it should be the comms engineers that actually lead this revolution rather than the broadcast engineers just collaborating with comms, because we're changing the devices that people can access media on, we're changing what they can access, we're also changing the mindset of the viewer that linear television is not the way forward. Linear television isn't the way forward, and we've got lots of research to prove it. We've also got new developments coming along. So, when we deal with different standards, we start off with dealing with them uncompressed so that we can work within a broadcast environment. So, standard definition was 270 megabits. HD was about between 1.485 and 2.9 gigabits. 4K is near enough 6 to 12. Well, we've got 8K coming as well. So 8K is between 48 and 96 gigabits per second. Okay, so good. There's a few of you in the audience going, huh? Gigabits per second? Yes, gigabits per second. However, we're not talking about delivering that kind of material at that rate to the public. What we're talking about, we need to consider uncompressed over how we handle them over content networks, and then we need to look at how we handle next generation coding over delivery networks. What we need are next generation codecs. So there's a fair few of them on that screen. Some of them are proprietary, some of them are developed by companies you're very well aware of. Cisco was primary behind Thor. HEVC, H.266, which is a new one probably to most of you, is on the test bed at the moment, and it's the next generation of coding related to H.265. But probably the most important one for you is AV1. Now AV1 came out of the Alliance for Open Media, and it is a royalty-free video codec that can work from SD all the way up to 8K. So it's got the potential to actually become a one-stop shop as a codec for distribution across Netflix. That's why Netflix is heavily invested in making it work for their company. They rely on H.265 at the moment, but they pay a significant fee every year. Every time you click and download, they're paying a royalty to the H.265 group that developed it. Every time you access that file, even if you repeat access it, they're still paying royalty every time that click is going out. So from a Netflix point of view, their business case, they need to develop something, and they want to develop something that is going to be more cost effective for them, and that's where we get AV1. Keep an eye on that. There's a Chinese version as well called AC2, which is also being developed at the same time with similar parameters. It's being developed with similar goals. So that would be useful to keep an eye out for as well. Optimize the codec, you optimize delivery to the public. Delivery to the public means access, it means money. There's a little tile at the top that says macro block for efficiency, wavelet for quality. And the reason why that's in there is macro block is the majority of those codecs on there, and that's traditional coding that you're used to. Wavelet-based coding, if you go to a digital cinema, that codec that they use is JPEG 2000, that's wavelet-based. So it's coding the whole frame in one go. Very bandwidth heavy, yeah, big files, okay? So why have I included it there? Because the cinema industry wants to consider how to deliver high quality cinema to the public as well. And you may get the requirements of wavelet-based codecs coming across your networks as well. Yeah, and dealing with them is tricky, yeah, because you have to handle them in a different way. So adaptive ADSL and fibre, you know, how you handled the rollout of fibre in the UK, how we handled optimising it, really enabled the next generation of media to be launched in the UK. If we didn't have this kind of support, we wouldn't have been able to roll out 4K with high dynamic range, with more luminance information, more contrast. Yeah, I mean, we were up till this point, all the terrestrial satellite, we were using a contrast level that was set in 1948, okay, because it was set for the CRT. And even when we changed to HD, we didn't actually change that significantly. Well, because of this collaboration, this has enabled us to start looking at HDR10 Plus is increasing the actual range of contrast that we can actually deliver to the public. Okay? As well as, it's not just resolution, it's resolution, contrast, and there's more factors to it. The Crown's an interesting example to look at. The Crown costs £150 million to make. Yeah, it's a very expensive series, one of the most expensive series. Completely distributed on OTT comms-enabled backbones. Yeah, so the model will work, and the because that was done in 4K for a 4K commission for Netflix, and it was delivered in 4K if you had a 4K TV to watch it on. It would dynamically adjust to give you the 4K stream. Okay, so what we've got is a potential to evolve that kind of high quality distribution, but not just into resolution. Now, VR and AR is having a bit of a quiet period at the moment, it's safe to say, the last 9 months, but it's also building on areas where it can work, areas where people can access it. Changing the devices, changing the way we actually deal with them is one big point, but adopting a part of the industry that actually can make use of that technology. There's no point in having loads of new technologies and they're lovely on a test bed, but if you can't find an application for them, people aren't going to want them. So what's the point? It's a waste of money. Sport is the obvious. I do a module with my third years, which is about VR and AR for sport production. Because it is, and I had to include Manchester City because obviously I'm a Manchester City fan. So if we can offer VR, we can offer AR experiences. It's all these added extras is what companies like Netflix, Amazon Prime are looking for, because you've got to subscribe to them, so you've got to offer them newer experiences, a wider range of experience, a wider range of material. So the title of my session was 8K Holography, Significant Tech Challenges on the Horizon. Well, in terms of data, network speed, storage, recently petabyte stores are becoming common in edit and render facilities to handle 4K and 8K workflows, because if we're editing them, we have to handle them uncompressed. Yeah, so we're talking terabytes worth of material for every production. Yottabyte and exabyte network and cloud-based storage facilities are standard for larger providers because they have to be able to support that CDN backbone. So that is putting increased pressure on your networks. But if you can roll with it and you can actually adapt to it, then you're in a really strong position to actually evolve where media goes next. Now that 8K, I mentioned 8K before, 8K, we started the Japanese broadcaster called NHK, they started doing tests on 8K actually about 12 years ago. They've been doing it for a long time. The photo, the main photo, is from London 2012 actually, and they did a number of 8K tests there. So it's 7680 by 4320, which means it's 16 times the picture information of HD. Okay, so it means you can have a 100-inch TV in your living room. Okay, and I did a straw poll. I did a walk round last night, and I got a group of delegates into my lab, and I said, "So, how many of you would like a 100-inch TV in your living room?" And there were a few who were up for it. So the real testing of 8K VR AR distribution has happened in all the major sports events over the years, because they're high-profile events, so it means it's a good opportunity to actually test the changes. All leading up to 2020. We're only 2 years away now. It's literally 2 years as of August. And the reason why it's important is, first of all, we're starting to see the display technology. This was at IFA a few days ago, actually. Both the largest display manufacturers, LG and Samsung, both launched 8K displays. They're commercial versions. They're holding back on the actual official launch, partly because they want to test the market. They're also holding back for launch events leading up to the next NAB. So we're going to see more 8K emphasis. And the reason why we need to talk about it is, it seems like, well, I don't want a 100-inch TV. Why do I need to talk about 8K? As broadcast engineers and as distribution engineers, we've got to tackle it when 2020 happens, because they're originating everything at the Japanese Olympics in 8K. So everything's going to be 8K, everything's going to be 60 frames per second, everything's going to be high dynamic range. So it means we've got to be able to deal with that massive data log, yeah, that's coming our way. Traditional video and audio completes the sensory information that we can distribute at the moment, but there are moves to include things like haptic and sensory data into media streams and expand that sensory experience, especially when we're talking about VR and AR supported solutions. So obviously you've seen, tactile gloves. It gives you some feedback to give you the information. What's new over the last couple of years is we're actually seeing display prototypes that can actually give you haptic information. So the display distorts to give you textural information, to give you temperature information. So potentially 5G could help with that kind of information, because you're looking at a broad house of applications for 5G. You're looking at autonomous cars, you're looking at Internet of Things. Well, if we could have more, not necessarily more bandwidth, but bandwidth used more efficiently in different ways, we could actually include things like that. This is, I got this from Ericsson's research, and it's a lovely slide, and my students love it because it's Guardians of the Galaxy, obviously, as an example. So 3G, it would have taken 26 hours to download it, so you could have flown to New York, from New York to Sydney, including checking time. 4G, working on a good day with a good supply of network time, average 6 minutes. And if we get to that promised land of 10 gig 5G, 3.6 seconds. Hopefully we'll get there. And one application that may need that extra bandwidth is holography, because holography has been a goal for us in the back of our minds. Forget affected 3D, that was just a burp along the way. Real holography is where we want to go with 3D. 1977, that's the poster that every engineer has on their wall. That's what we want to get to. Help me, Obi-Wan Kenobi. Well, as of November, Red Cinema, who developed one of the delegates actually asked me about The Hobbit last night. Well, The Hobbit and Lord of the Rings were shot with Red Cinema cameras. Well, Red Cinema as a company have developed the first holographic supported mobile phone. And it will the first prototypes are in test at the moment, and the launch is supposed to be between November and NAB next year. That's the camera that they're using to shoot the H4V material, and it's not an accident that it's a mobile phone that they're launching it with. They're not launching it with a TV, they're not launching it with anything else, it's a mobile phone, because it's squarely targeting your industry. So, to finish off, increasing resolution 4K, 8K, increasing dynamic range, contrast information, increasing angles and methods, VR and haptic, increasing colour space, the range of colours we can support, possibly to support holographic material in the future. Bandwidth and infrastructure need to be more flexible, adaptive to change, and for media growth and markets, that's key. If we can work together and we can adapt the next generation of engineers, the next generation of infrastructure, it can actually support a wide range of supportable media, not just one television standard as we used to do. Okay, hopefully you enjoyed that.